So the original intent of this class was that I was thinking at this point people would struggle with some issues with their project, so we would do a troubleshooting class. But it doesn't look like that we need to hold the hands of these the final students. These are the strongest from the crop. And most of the issue turn out that it's very effectively dealt with on Discord when they just post question for each other and they kind of resolved it. So I think it's great to have you here to talk about. You want to talk about airdrop and some other trick that actually I think would just be useful for them as they get to launch the product.
Awesome.
Yeah.
Are
So
we,
Boris,
are we complete?
yeah.
Okay, so let me start sharing. So I'll be talking about today about slowing, okay, about seeking Merkle airdrops. So I got into this because this is an issue I've been dealing with, and I've been trying to figure out a way to do this, and I'm adapting what Arisen Horowitz is doing for NFTs. So I went deep into this. So they asked me to talk about it, something about zero knowledge related. So I'm doing this. I found it actually really useful. So first, why zero knowledge maker airdrops? So first, making an airdrop is easier if you already have the addresses of the people you are airdropping, right? You need like a list of addresses, and then you can go there. Usually, sometimes they use a contract. They put a list of addresses, an array of addresses, but you may want to do to distribute some doing the airdrop based on some kind of off-chain activities, not necessarily through something related with being in a list in a contract. Also, this is not if you use the list on the contract, it's not private. So everyone will know that who received the airdrop, right? So the solution will be to do the airdrop to some users that can provide a message, a commitment, the message as a commitment through a public channel. Anything, it could be from Telegram to a website or anything, and later claim the airdrop by providing the proof, the CK proof that they're eligible to receive the airdrop. So that's the idea of the Merkle the CK airdrops. So basically, if someone looks into the Merkle tree, they will just see a bunch of proofs. They will know. So in the identity of the person receiving the airdrops, the people receiving the airdrop will be completely protected. They wouldn't know who is receiving the airdrop. So that's the main motive behind trying to do airdrops using a CK Merkle trees. So then how this works. So basically the user provide a message, a commitment that is safe. It will be safe to send. And in my demo, we'll be using a website. And this commitment is done using hashing a key and a secret, basically. So the whoever is administrating the airdrop creates a Merkle tree with the commitments. It will be, in our case, this library I'm using is using the Merkle tree of what is called MIMC sponge hashes. That's and they just deploy the Merkle tree on the smart contract. Then that's a type of the user just generate a proof with the key and the secret, and using a circuit, and and then collects the airdrop. That's what it's basically in general what it does. So this is how it makes a proof. So what is represented in red is the public, what is public, and what is in blue is private. This is the circuit that is reproduced on Circum to do the proof. Some basics I want to do. The commitment scheme is called the Pedersen commitment schemes. So basically, it's a very efficient way to do the commitment, right? Is the reason there is a 4-bit basically, and it's very efficient. So it's very good to, it's very attractive to be using circuits with CKS NARC proofs. So there's a lot of documentation about this specific scheme, but the basic idea of they are using this is because it's very, very efficient. So based on the basic idea of the commitments, I'm not sure how deep I can do the commitment, but it's the equivalent of writing a message in a sealed temper evident individual number and on or countersigned envelope, and that is kept by the who wrote the message. Of course, the envelope, the content cannot be changed, and the message cannot leak. So that's the equivalent of using this. So this is how this is translated using doing it in a CK, right? So it's basically well, let's assume that Anna and Bob decides who gets to be bid first in an auction, and Carol acts as a referee. And it is agreed that if Bob can guess what is Anna's choice, Bob gets the first bid, or if otherwise Anna gets the first bid, right? So what is happening here is, so that's the type of 2, is Anna decides, let me fix something, it's a little confusing. One here. So let's go back to this. So basically, Anna's secretary decides the message between 0 and 1, then decides a random secret, then produce a commitment, the message, the commitment on a random number, and using a random a public method. So then announces what the commitment is. Then Bob announces the guess. They doesn't know the outcome at this point, but Anna does. And then Anna says, okay, this is the message I got, this is the R I got, the secret I got. And then Carol checks if it fits, and then they decide who wins the bid. So that's how the step by step is happening using a commitment scheme, a Pedersen commitment scheme. A little more about the hashes is MIMC is just a family of block ciphers and function stuff, but they use some mode. I consider something called the sponge mode. That's basically is a minimalist way to a minimal way to create the circuit, right? So it's basically use a fixed length permutation and a pairing rule, and to create a function that maps a variable input to a variable output. So it's quite simple, very efficient. That's the reason they will use this one in this specific demo. And a little about the code. Basically, it used the Merkle Airdrop lib library, and it basically it helps you create a Merkle tree. It lets you create I can't say this, the Merkle tree storage string, have all the functionality there, and so then you can generate the proof. So this library in specific give you these 4 functionalities that let you create the Merkle trees, create the string to store the Merkle tree on the contract, and then let you generate the proof. That's what this library does. So I will do a short demo here, how it's going, how it works. So basically, you can ask to collect some. I'm here. This is using hard hat in the local node. So if you don't have any coins, you can request the coins here, and then you have to let me. This is my NFT account. So I connect the MetaMask, and then I need to. Okay, so I need to. The contract at this point, the contract will be deployed. Give me a second here. Give me 1 second here. where I did the, where's so many files here. 1 second, I will find it right away. Okay, let me move to this, the other side. Okay, now I'm fine. Okay, so when I committed I did the commitment, it gave me this, the address. So I just basically put the address, the token address. This is the token address of the wallet, right? The one that is actually receiving the airdrop. So then they will have to let me, I have some, at least with secrets here at some point. It's here, okay. So I take some secret. It's here, okay, sorry. Then I get some secret, I probably have some secret here, I haven't used. And then you need the contracts of the airdrop contract. You put it here. And then you basically, you first calculate the proof. It will take around 30 seconds or something. You will calculate the proof. It will take a while. I will go to the code a little later. So I just want to see you guys to see how it actually works, what it actually does. Okay, so now you have the proof. So you see, it only has 20,000 satoshis, and then when you collect the drop, I already used that. Sorry, I need to use another. Yeah, I did the. So let's start again. I want you guys to see this. So I need to put the key, has to be different. Doesn't have to see it, doesn't have to be the same one. I think I didn't use this one, right? So this one, let's get the contracts again. Here I'm using this one. Okay, so now you see I have only 2,000. You calculate the proof. It takes a while. So when it calculates the proof, basically collect drop, it will send the proof, and the private airdrop contract will validate the proof with the Merkle tree it has there. And if it's verified, it will basically give me the tokens. So when I collect the drop, it will now, of course, it will launch my MetaMask again. It will tell me the fees on ones and stuff. And then it should have like 3,000 here. There you see. So okay, 30,000. So that's the basic functionality of this demo. So what I'm doing now is I'm modifying it so it will give an NFT instead of just once. I already deployed some on the Ethereum Harmony testnet. I was actually planning to do this demo with the NFT, but it's being delayed. But eventually it will be ready, and it will be easier it will actually simplify the process of doing the airdrops a lot. And so you need, I wanted to show you something here. You need, at some point, you will need to I didn't talk about this. You need to create the circuit, the circuit. You have to create it using Circum. You have to compile it entirely, and you have to create. There is some libraries to create the Merkle tree. So the zku and Merkle tree. So those work like this. So basically, it will take some. Let me do this as long. Oh, I'm in the wrong one. Sorry. So it should be here. Okay, so here. So you will have to generate the WASM. You have to create the Merkle tree from a text file, and then you have to import this into the library, and they will put in the smart contract. So it's a little gas expensive on Ethereum. It's much better on Harmony, but it actually works. Harmony works really well. I did try to do it, going in Ethereum in Robston, but it was giving me tough time with the gas. So, but in Harmony it's actually working very well. It's using the library. This one. This is the core of the whole thing. It's the library. It has all that you need to create the Merkle tree, to create the commitment, the witness. It's actually the core functionality is very easy to implement. You need to when you start adding front end, you need a little. It will take a little more time, but this library is actually really simple to implement. And that's basically where I am in this. I don't know if I will expand the presentation, the slides, to add all the papers that's supporting this. This is this is based on what other I forgot what their guys are doing. It's based of what these guys, Tornado Cache, I think, it's something that they're using it. So I base a lot on what they're doing it because they have implemented the patterns and commitment schemes. They have it very well, defined. So it's just, I'm just adapting it so it will, work with NFTs. It has some particularities, but the general idea is it remains the same. So the code is, I will actually branch the code. So once it's ready for NFTs, so people can use it, and hopefully it will be as efficient as it is right now with just giving tokens. I have the file. I will have the files so you can generate the circuit, and so you can create your own scheme, and you can create your own hash traces and hash trees. So yeah, that's what is right now this zero knowledge using airdrop using zero knowledge. That's the status right now. I don't know if you have any comments, some areas you want me to expand.
It sounds great. Maybe let's see if there are questions about this. I think what I like is someone actually might get to use it. I'm not sure about the projects, whether someone would have a token. I think they don't at this point, but eventually someone might, and or NFTs for that matter to airdrop. I think Don has a question that isn't about this, but if we have time, we can maybe see we can go through that too in a chat. So it's really about just batching a bunch of MetaMask. I think it's something that maybe not particularly CK related, but I'm sure Boris, you had to deal with this at some point too, right? Doing these one anchor, all these issues.
Yeah. So let me see the question. I wanted to say about this one. I mean, this actually is using the airdrops is actually fixing issues that we are facing right now in Harmony. We are trying to do airdrops, and it's getting complicated, and also there is a lot of issues with privacy. That's what brought me into this, right? I wanted to do something that is, as you said, usable and like a practical, fast utility. That's what it brought me. Okay, let's try to figure out. So I use, I mean, I'm not the first one of course thinking about this. So I use some of the libraries there are, and I think it has a lot of potential. I will definitely keep pushing on this once I finish with the fixed income that is next week. I will try to make this something probably that we will not deploy, but add it to our GitHub so people can use it to their own product. Some kind of toolkit for people wanting to use Harmony to do airdrops. That's the approach I have to this. The circuits with Circuit wasn't that simple, but I mean, if you did the course, you should be able to do it easily. And actually, when I was trying to do, I went back to the first, I think, first two lessons, and I use it to try to create the circuit. So it's actually a standard circuit, no, the same thing. And probably if you need to understand a little, it was for me a little trying to understand how actually the hashes, the means what hashes work. And I definitely recommend to you guys to read about this thing if you want to explore how can you make your things more efficient. I definitely recommend look into this. I will add all this to the presentation, but it's a presentation very useful here. How this, I don't even know what my email is. I will have it here at some point. It's probably here. Okay, so it's here. Send. Okay, I have those here. So this is, where is them? It's called, let me see if I can find it. This second is what's it called? Okay. Oh yeah, now it is. So this presentation, this PDF, this was actually really useful to understand these minimal commitment schemes. I spent a significant amount of time trying to understand the cryptographic part of what it means to make a commitment. And I saw that this specific one, the even man source scheme, was very common. Common, I don't know if very common, it was common. And this presentation was actually really good. So I will add that all to the presentation. And if you really want to go deep on the commitment schemes, this is very useful and kind of, for the complex and the dark, it is kind of easy to understand. So I will add this to the presentation. So this is this is all I have on this on the airdrops. I will put a GitHub so everyone can use it. I will keep updating the GitHub, especially after next week. And if anyone needs help to make them work in their projects or something they want to do on the long term, I'm definitely open to help in anything you guys need.
There's a question in the chat. I wonder. I was talking about. Can you take a look and see whether
okay.
You may want to say something about this? It's actually unrelated to what you just talked about. But
yeah. Let me read.
That's okay.
Okay, now I see. Who's this? Dan, dude. I've been dealing with this for a long time, right? Cross-chain specifically has an issue that requires many approvals, right? A standard cross-chain transaction requires 7 approvals, and definitely is a degrading experience with MetaMask having to approve. So there are some approach. It's called manager contracts. It depends on what exactly you want to do, but basically you are delegating some of the approvals to a contract, and then you just approve the manager contract. It has its pros and cons. For me, the biggest con is if you don't have one that is already there and is proven to be secure, and you have to do your own, it will be a big risk, because the contract will have, let's say, a lot of power over the transactions. So it's hard. Sometimes in my case, it was hard to find one that it fits what I needed to do, right? So I had to rely on create my own, and you have to go through a third party to verify it, that is secure, all the stuff. So the answer is yes. But if you don't have one that is already there, I don't know, open zeppelin or something, it's, it probably won't be secure enough. You need to run it to all the third parties verification and stuff. In the meantime, for the final project, I think you have to live with 2 or 3. I don't know how many you have, but if you're 2 or 3 pop-ups of the MetaMask, people is fine with it, and it's considered not the best, but it's not the it's not the end of the world. And I think it will take you a long time to do it, if you don't find something custom for what you do, specific for what you do, create a one. It will take a significant amount of time to go through that process. So search for contract managers. There are many. Basically, all bridges, all DEXs have at least one kind of a contract manager contract, and well, 3 to 5. Yeah, I understand. I'm dealing with this, and actually, in one of our projects, I'm stuck with that. I was able to reduce it from 7 to 5, but that's it. That's all I could do. So yeah, try to see if you can find a manager contract that's already there. If not, you know, in the meantime, they will have to click a lot of accept, and yeah, you have to live with it. So sorry, and this is probably the biggest issue, right? Well, you can always, if you're using MetaMask, right? So probably you can always put some of the processing on the back end, right? So, but then you lose the trustlessness, right? You can create a contract that basically you put in the backend, you put the private key and, you know, the whole thing. So it goes automatically, but I assume this is not what you want to achieve, right? So there are ways to, if it's for a demo, if you want to improve the user experience just for the demo, you might want to pass something to the backend in a contract that you control. So the approval of the contract is made, I don't know, using, you know, you just put the private key in there, and I put .emp file. I don't know. I probably can show you something how I did it here. Actually, I'm doing it here. So let me find some one of my EMB files here. So you create one of the EMB files, and they will have you put the private key here. So the backend processes, you know, doesn't require MetaMask. You just do it here. They do it automatically and take the seed phrase or the private key from here, right? But then you will be the custodian of the assets while the funds are going through your contracts, right? Oh, I'm not sure. Sorry, sorry about that. Yeah. Now I share. So I'm sure you're familiar with the EMB files. So you just create an EMB file. You put the keys, and then you call it using. I will stop sharing for a second because this one has an actual key. So let me put something that I can actually share. Where is that? That is the key. I know I put that key here somewhere. I don't want to share.
Good to be careful. This is recorded to share.
Yeah, I almost do it, man. So okay, where is this? Where is? Okay. Get there. Okay, Arc Harmony. Let me make sure that key is not here. I don't know what it is. Okay, here it is. So let me I don't know. Let me remove it from here for a second, and then I will share my screen again. Sorry about that. So let's share screen here. So what I'm doing in this one, I'm calling the contracts directly using the mnemonic. You see, the mnemonic was here. I just deleted it, right? So part of the process is automatic. It doesn't have to go through MetaMask, but it happens on the back end. So for demos, this will improve your user experience, or even there's a lot of projects that use this. Anchor Earn does it like this, but they have a strong security of they put it on an EMB file. They use the AWS security for all the stuff. But and then more importantly, it will not be trustless, right? You will be, while the funds are going through your contracts, the money will be yours. So you are in charge of doing, you know, if something happens there, it's your money, it's your funds, your tokens. So that's another disadvantage of going in this direction. But, you know, this will be an option to reduce the numbers of transactions that have to be approved on the MetaMask. I guess that's all I can give you, but it's an issue. It's an issue. Eventually, there will be better, but they are not so far. That is even a Harmony bridge to bridge from Harmony to Ethereum, you require 3 authentication, 3 approvals, right? So yeah, we have to deal with it. There's nothing we can do in the meantime.
Yeah, Boris, may I ask, actually, this is probably outside of the context of this, but eventually when we have cross-chain API, is it supposed to resolve some of these issues?
Yeah, the cross-chain API is there and it works. Just the user experience is not good. Yeah, it requires seven authentication. So we came to
would there be some next generation of cross-chain API that doesn't have that?
Yes.
Because like when you do earlier you talk about the fixed income protocol. So when we talk about doing it through one anchor or ETH anchor, when we try to access Terra's anchor 20% fixed rate, and there you don't need to approve, right? It seems to be much more smooth.
Yeah, it only needs one approval because we are it's not completely trustless. Once the tokens go out of Harmony, it goes to a Harmony contract, then it goes to an anchor contract that belongs to Harmony. So we will take ownership of those funds for a few seconds, a minute, but it's not completely trustless, right? And yeah, it's something we have to deal in the meantime. I think the solution is zk. I think solution is become a layer 2 to the layer 1s and use that to bridge somehow. So Ganesha has some ideas on that, but the conclusion we have right now, it requires more research to find a solution for this. But right now it's like that. Is either we get some custodian we become custodian at least for a few seconds of the assets, or we ask a lot for transaction for authorizations. And yeah, so that's an open issue. Probably someone in this class fix it.
Yeah, actually possible, because we've decided we're doing next round. Actually, just at this Thursday, Ganesh is coming to have a chat about some of these issues. I don't think we would do a final project on this so quick, but the next kind of round of this course will start in March after ETH Denver. Then we hope to get more into infrastructure, and this will exactly be what you will learning next. Yeah,
I will jump into that right after these 2 things are coming. I will try to fix the cross chain using something different, something new that makes the user experience better. That's it. And because that's my main concern, the main concern that people express us, especially from outside, they are not technical. They say, oh, the user experience sucks. And yeah, when you come to the conclusion that you are in the best possible experience right now and it still sucks a lot, so you figure out we need a different approach. Probably that was my main, it's called mistake at the beginning. I tried to make it work with something, it wasn't being innovative enough. So we need to do something. We need to do some research to fix that issue.
Okay. All right. Any other questions from the class or the TAs? Well, if not, then I think again we can close it early, because I think people are busy building. They're racing towards the final project deadline. I mean, there are multiple deadlines. If you finish the earliest deadline, that will be amazing. But remember, next week all of you have to give a short few-minute presentation on your project, regardless of the status. So it's a good thing that we try to work hard right now. Yeah, I shouldn't keep you here too long either, Boris. I know that you have a million other things you're doing for the Harmony.
Yeah, I need to deploy the fixed income by next week, so I'm coding. So, and I will polish the GitHub of the airdrop. I actually believe this has a lot of utility. If you guys, anyone can play with it and change it and improve it, just let me know.
That will be great. Thank you so much. Thank you so much. All right, then. Thanks, everyone. Thank you,
everybody. Bye.
See you Thursday.